Today what we're going to talk about is lesson 3-1, constant change, and the graph of y equals mx plus b. Should be a review, especially from Algebra 1 and geometry. This is a slope-intercept equation. Okay, slope is m, y-intercept is b. If y changes by a constant amount m as x increases by 1, then y equals mx plus b for all x comma y, and the graph of the points x comma y is a line with slope m and y-intercept b. In example 1, it says Noah usually waits until he has only 1 gallon of gas left in his car before filling up. Suppose the gas pumps at a rate of 6 gallons per minute. Write an equation for a function representing the amount of gas in Noah's tank x minutes after he starts pumping gas. The tank holds 17.5 gallons when full. So I'm going to call this amount. So that's my function. So the amount in terms of x, so I write a of x. This is function notation, remember people. A of x equals, how much gallon of gas does he have? Well, it says he usually waits until he has 1 gallon of gas. So he has 1 gallon of gas in his tank. He's never completely empty, because if he was completely empty, he wouldn't get to the gas station. Okay, so he has 1 gallon of gas, and he is pumping gas at a rate of 6 gallons per minute. Remember, rate is the same thing as your slope. So when we're looking at this, mx plus b, here's b, this is my y-intercept is 1, plus, since he's pumping gas in, it's plus 6 gallons per minute. How do we say 6 gallons per minute? Well, x is our minutes. So 6 gallons per minute is 6x. Now, we can graph this to see how long it takes the tank until it gets to be full. So on the next slide here, you see my y-intercept is 1. It goes up 6 over 1, up 6 over 1, up 6 over 1. Here's 1, up 6 over 1, up 6 over 1. Okay, you get all these points. And as you can see here, at a roughly about just under 2.8, okay, if you see here, this is about 2.8. Okay, so we could say at about 2.7 minutes, the tank is full. Okay, 17 gallons of gas, 2.7 minutes. Yeah, try that. See how long it takes you to fill up your car. The y value of the point where a graph crosses the y-axis is called its y-intercept. You need to know that. Okay? And should already know that. It's called its y-intercept. The graph of y equals 6x plus 1 crosses the y-axis at the point 0, 1. So the y-intercept is 1. Whenever x is 0, you have a y-intercept. Should be a review. Okay? The slope of the line is the rate of change. 6 gallons per minute. That was my slope. You can verify this by finding the slope between 2 points. So they picked 2 points, 0, 1, and 2.75, 17.5. y2 minus y1, 17.5 minus 1 gives me 16.5. 2.75 minus 1, x2 minus x1 gives me 2.75. 16.5 divided by 2.75 gives me 6 gallons per minute. Okay, it should be easy for you. Slope-intercept form. A function whose graph is a line or part of a line is called a linear function. In general, linear function is a function that can be represented by an equation of the form y equals mx plus b. The form y equals mx plus b, or f of x equals mx plus b, this is function notation, is called slope-intercept form of a linear equation. Although the letter B is commonly used for the y-intercept, the letter M commonly represents the slope. That should be review. M is slope, B is the y-intercept. Any other letters could be used in their place. Example 2 illustrates how the slope and the y-intercept can be used to graph a line. So let's move on here. Example 2 says, a pond with about 26 acre-feet of water needs to be drained for repairs to its levee. Engineers determined that 8 acre-feet of water can be safely drained per day. Write a linear equation to model this situation. So I'm going to say drained of X, okay? Because we're draining the water, okay? Or I guess I could have said P of X because we're draining the pond. But, so, draining this. Oh, they want a linear equation, sorry. I'm doing an f of x equation. I'm just going to use x and y then, okay? So I'm going to write y equals, remember, my y-intercept is my starting amount. What's my starting amount? My starting amount is 26 acre-feet. So I'm going to say 26. And I'm draining water, so it's going to be minus. And how many acre-feet am I draining per day? Well, I'm draining per day 8 acre-feet. So 8 per day, so it's going to be 8x. Everybody see how I got that? Starting value, this is my slope. I'm draining 8 per day. And how many days will the pond be empty? Okay. Well, if the pond's empty, that means my y is 0. Okay. Or what I could do is I could put this on my calculator. So type in 26 minus 8x. I'm going to graph. And if I scroll out here, because I'm scrolling out to my time, it is going to be drained just a little bit over 3 days. So approximately 3.2 days. About 3.2 days. Okay, simple. C says, what are the y-intercept and the slope of the line? Well, my y-intercept is where we started at, which is 26. My y-intercept is 26. And slope equals a negative 8. Don't forget to put that negative in there. We have negative slope because it falls. It says, graph the line and indicate the point where the reservoir is empty. Well, our reservoir is empty when x equals 0. So if you look at that, we start at 26, okay? And we said it was dry about 3.2 days. So here's 3. And this point right here is 3.2, right? And this point right here is where reservoir is empty. Okay? When y equals 0, sorry. When y is 0, that's when the reservoir is empty. Okay? They showed us the graph right here. Technically, they said it's 3.25, okay? But yeah, here's 26, my y-intercept. I'm falling all the way to about 3.25, so I was right. There's my point, and that's where the reservoir is empty at, when y is 0. Okay? The x value of the point where the line crosses the x-axis is called the x-intercept of a line. Point where the line crosses the x-axis. In example 2, it intersects the axis at 3.25, 0. 3.25 is the x-intercept. That's where the reservoir is empty. In constant increase situations, such as example 1, as the value of x increases, so does the value of y, the slope of the line is positive. The graph slants up to the right, and the function is said to be increasing. Okay? Up from left to right, increase slope, or positive slope. If it falls from left to right, we have what we call is a decreasing function, which means we have negative slope. Once again, this should all be a review. When the slope m equals 0, the graph does not rise or does not fall. The graph does not rise or the graph does not fall. The function is constant. A line with a slope of 0 is horizontal. A line of a slope 0 is horizontal. Vertical lines have undefined slope. You need to know that. Those are key important pieces of information. If you have 0 slope, you are horizontal. If you have undefined slope, what you have is undefined slope. So if you look here, they have a picture of increasing slope where slope is greater than 0, so it goes up from left to right. Here's a picture of decreasing slope, which is falling from left to right. And here is a horizontal line where slope is equal to 0. Put that picture in your notes. Parallel lines and slope. Consider the graphs y equals 4x plus 7 and 4x minus 2 at the right. Okay, here's 4x plus 7. Here's 4x minus 2. It says both lines have the slope 4 on each line. As you move 1 unit to the right, the line rises 4 units. So I always say up 4 over 1. You get the same thing, up 4 over 1, or over 1, up 4. Same thing. It has positive slope. In the figure at the right, triangles A, B, and C and D, E, F are congruent by side angle side congruence theorem. So the angle CAB and angle FDE and these lines form congruent corresponding angles with the y-axis at A and D. Consequently, line AB and line DE are parallel. Okay? Which leads me to this that you need to write down. Two lines have the same slope. They are parallel. Two lines that have the same slope, they are parallel. Write that down. These two things will never intersect because they have the same slope. Consequently, we have shown that the following is true. If two non-vertical lines are parallel, then they have the same slope. So if you have two vertical lines that are parallel, then they also have the same slope. If you have two non-vertical lines are parallel, then they have the same slope. Okay? This is a theorem that you're going to want to write down. Two non-vertical lines are parallel if and only if they have the same slope. If they don't have the same slope, at some point in time, they will intersect. Okay? That's all I have for you today. Thank you very much. We'll see you tomorrow.